Rosemary, are you on?
Yes.
Eunice?
You can press X on top.
Thank you. I never needed to do it, so I never thought about it. Very bad, Sam, very bad. Thank you. But we all can see it, still see the screen, right? Okay, question 8. Not that we mind so much about the multiple choice. And I think that's a good point to make, actually. Don't forget, these are multiple choice, so sometimes you might not need to do as much math as you might think. Just saying. I don't know for this question, but just in general, just keep that in mind. Okay. Recording's on. Yes. Very good. Close it. Using the trapezoidal rule with 4 sub-intervals, which expression gives the approximate area. All right, trap rule. H over 2, first plus last plus 2 rest. Thank you. 2 times the rest. H equals B minus A over N. N is the number of sub-intervals. B is 3. Take away A, which is 1, over N. 4 sub-intervals. So 4, 2 over 4 is a half over a half is a quarter. So already these ones are out. Right? Then I'm looking and I'm like, well, these two match and these two match. So it's literally, what's the difference between the two? It looks like one's not multiplied by 2, the other one's multiplied by 2. So if I had to take an educated guess right now, I'm going to say the answer is A. Obviously, it could not be. It could be a trick and I could be wrong. It could be in B. So we're going to actually do it. But I was just trying to show you how to kind of navigate your way through multiple choice questions. With me? We do the table. The table is looking like this. There's X, there's Y. You start off at 1, 1.5, 2, 2.5, 3. At 1, it should be e to the power of 1. At 1.5, it should be 1.5 e to the power of 1.5. 2e, 2, 2.5e, 2.5, 3e, 3. I think we know the answer is actually not A now, and it's B. Why? Because what's 2 times the middle? 2 times 1.5? 3. What's 2 times 2? 4. 2 times 2.5? 5. So the final answer would look something like this, right? A half over 2, first plus last, plus 2 times the rest. 1.5e, 1.5 plus 2e2 plus 2.5e. I think you guys get it. I'm not going to expand it. And then it becomes 3, 4, and 5. Clear? 100%. So my assumption was wrong. Oh well. Looking good. Let's go. Next one. What's another one you guys had problems with?
13.
13. How many times have we seen this style of questions by now, yeah? That's good. It's good. When you start to feel like you're doing more and more exams and things are starting to repeat themselves, that's excellent. Ah, our favorite one. What kind of skill? Yeah, what kind of skill do you need to use? Reverse chain. It's good that it's good to be aware of it.
Will we bring it upstairs?
Tell me why would you have thought it wasn't? So what was your initial idea then? Just to integrate it normally?
I was just like...
What the hell do I do?
Yeah.
Well, because you can't, let's recap something for integration. It has to be linear, like that, linear, for you to be able to integrate. Remember, the inside has to be linear. If the inside is not linear, you can't do it. That's problem number 1. Problem number 2 is there's no product rule. You see how they're multiplied? There is no product rule for integration. So when you see a product rule, you've got to think about reverse chain. And then there was 3 steps for this. Step 1 was take a guess. Step 2 was differentiate that guess. Step 3 was adjust. So step 1, can somebody give me the guess? What they think is the answer at least? Who cares if it's wrong? Just tell me what you're thinking.
X cubed plus 1 to the power of 11.
Take a guess. He's saying power of 11. Then we're going to differentiate that. Becomes 11 bracket x cubed plus 1 to the power of 10 times. Differentiate the inside 3x squared. Why are you saying 2x? 3x squared. Then that becomes 33 x squared. Hey, not a bad guess, right, you guys? You gotta give it to him. He was pretty close. The only difference is his guess gave us an extra 33. That's when you get to step 3, you adjust. So what's the actual answer? Step 1, he took a guess. Step 2, he was bloody close. Step 3, he needs to adjust his answer. So what's the answer? Step 1 divided by 33 plus C. Come on, you know you've got it.
That's the answer.
That's the answer. That's it, finished. Do a little bit more and you'll get there. Very, very good. Take a good guess, adjust it. Sorry, differentiate it, adjust it. Guess, differentiate, adjust. GDA. Gadar. Gadar. Okay, shall we just do one more?
Can I just quickly?
Yes, on the side we'll do one more. Make up one, because if you can know how to make up one, then you definitely know how to integrate one. Make up one. Anyone, again? You want to leave it to him again? Let Sandra make up one.
Same thing, but the X is on the bottom, that quotient.
Yeah, but it doesn't work like that, because what you got to remember is it's got to differentiate. But I'll do what you want. You want it at the bottom. Remember, you got to think of the derivative, right? Think of its derivative. Anyways, let me do what you want. Okay, yeah. Integrate e to the x over 1 plus. Nah, that one works. Let me integrate x e x squared dx. We'll do one of these ones. Step 1. Don't take shortcuts from me. Tell me what your step 1 is. What's your answer at least?
EX cubed.
EX. Yeah, I think so. Why? Why is it squared and not cubed? What's the difference between exponentials with powers compared to just normal stuff with powers? That one. Powers don't change. Powers stay the same. Whatever. For exponentials. Don't forget that.
So that's not EX bracket to the power of
Even if it is. Even if it is, it's not like that. Exponentials don't change like that. You're thinking of 1 plus e to the x all cubed. That's different now. But if it's just ex to the power of 3, that's... Okay, that's our guess. What's step 2? What's the answer for step 2? So tell me, what is it?
2x.
Yeah, and look, again, it's bloody close, so not a bad guess. The only thing is I've got an extra 2. So step 3, actual answer is ex squared over 2 plus c. Good. That's a hard skill to master.
Is it supposed to be ex squared or just?
Is it meant to be ex squared? But wait, let's get that clear, right? That's what we wanted. This is what we ended up getting if we chose that as a guess. But because we've got an extra 2, which is so close, I'm going to get rid of that 2. How? I'll go, it's ex squared divided by 2. So when I differentiate this now, I'm actually going to get the line in the blue, because the 2's will cancel out technically.
So
Yes.
if we were to write like our answer answer like that? Wouldn't we like lose marks?
No. That is how you do it. Just do it. Don't worry.
What would you do instead? What would you write?
I don't know. I just remember like in my previous exam,
Yes.
I didn't write like you know how it's limited h to 0.
Yes.
Yeah,
That you lose a mark.
yeah.
That's different.
That's
Oh,
Yeah. No. So that is how. So with this, you have to take a guess first. Then you got to differentiate. Some 3-unit students, just so you know, will not even do 1, 2, 3. They're just writing EX squared over 2. Just depends. I'm doing the steps. Do you have to do the steps? Absolutely not. You can just jump into the answer if and when you're ready, just jump straight to the answer. That's how it's taught. Reverse chain rule is actually meant to be just done in your head, but I'm doing it as 1, 2, 3. But yeah, absolutely fine. Working out. Okay, I would never show you something that doesn't work. I would not do it. Can we do another one? Yeah, let's do another one. Again, do you feel like you can make up one? All right, I'll do one with a surd. So, okay, here, I'll do the surd in the inside. And what do you think needs to be in the outside? What do you think needs to at least be in the outside for this to be a reverse chain rule? Yeah, x squared. It can't be x because what's the derivative of x cubed? What are giving you x squares? So it can't be x. Yeah, we're starting to realize when it will be a reverse chain rule question. Okay, what's your guess at least? Remembering that when I differentiate, I needed to get to the power of a half. Remembering when I differentiate, I need to get something to the power of a half. So I think we all agree it's going to be that. To the power of 3 over 2. Why did you say 2? 2 on 3. That's a third when you take away 1. 3 over 2.
I feel like I'm confusing that with cross method for non-monks.
Okay, you feel more comfortable with PSF?
Yeah, because that's what I did.
That's okay.
Is that alright?
Yeah, that's okay.
Done.
For now.
Thank you.
All good. 1 plus x cubed to the power of 3 over 2. Differentiate. 3 over 2. 1 plus x cubed to the power of a half. That's when you're happy because you're like, all right, that's exactly half times 3x squared. You're even happier because now you've got x squared as well. But the only thing is you've got an extra 9 over 2. 9 over 2 x squared root 1 plus x cubed. 9 over 2. You don't want a 9 over 2. So what's the answer? You don't want that 9 over 2.
2 bracket 1 that over 9.
Is that what you were trying to say? Yeah. So 2/9 1 plus x cubed to the power of 3 over 2 is the answer. Because you're dividing it out, right? So you don't want the 9 over 2. The division of 9 over 2 would be 2 over 9. 100%. Okay. One more still.
Sure.
I'll change it up again. I'm just giving you all the different functions you can have. So this is going to be a good video for you guys. What about this one? Sine x cos squared x. See how I needed to have sine if I'm going to have cos squared? I can't just have cos squared. I can't. But when I have sine in there, it's very allowed because when I differentiate cos, it's going to give me sine. All right. Step 1. What's your guess? Take a guess. You shouldn't be thinking. You shouldn't make it into a negative yet. Take a guess. You shouldn't be thinking. Really, there's only the one that you can take a guess at.
Cos x all cubed.
Yeah, 100%. It's got to be the one with the power. If you haven't started realizing that, it's the one that's got the biggest power and stuff like that. It's just how it is. Like here we chose the x cubed plus 1. This one we chose the ex squared. This one we chose the surd. This one you're going to choose the cos. That's just how it works. Cos x to the power of 3, or as he said, cos cubed x. Same thing. All right, step 2. What's the derivative of that? 3 cos squared x. What's the derivative of cos? Minus sine. Hey, again, look, very close. What do I have extra?
Negative.
-3, so therefore the answer is cos cubed x on -3 plus c. %?
95.
Oh, that's pretty high. That's still pretty high. I'm happy with that. Because this skill was only ever taught to Extension 2 students. It wasn't even taught to Extension 1 students, let alone advanced. So if you're saying 95, that means I've done a pretty good job. But there's a trick to it. If you start to learn the trick, then it gets pretty comfortable. Okay. Next question. What's the next question? Enough of this reverse chain rule. Part B. Fair enough. I didn't know there was a part B. So let's recap. What was our answer for part A? Our answer for part A was x cubed paste x cubed plus 1 to the power of 11 over 33. I just need to write the question down because I've forgotten it. Integral of x squared x cubed plus 1 to the power of 10 dx equals. Okay. Okay, understood. Find the value of A given that 5 marks. Okay. All right. I'm thinking. So give me a second as well for me to think. Aha, I see it. I see it. And that's very interesting they did that. Part A and Part B, I don't think are related. Yeah, it doesn't apply. They're not linked at all.
In some other questions.
Yeah, it's very bad that it did it like that. Usually it's not like that. Part A, Part B actually means they're related. That's okay. Don't know how much of this you guys are used to, but can somebody tell me the integral of this? Straight away. Yes, why? You actually can see it? All right, let's just say we didn't know that at all. Can somebody tell me another way they can realize it's that? Thank you. You laugh, but you'll be surprised how many of you would have not put that together. You know I'm not wrong. So if you were struggling with the integral, you're meant to look at the right-hand side and be like, hold on, it's a log, but oh yeah, derivative of the bottom is in the same power family as the top. Yep, that's a log. So let me go back and talk about that again. What's the derivative of the bottom? 2x minus 2. Is that the top? Obviously not. But if I factorize the 2, can we see we actually get the top? So it is in the same power family as the top. All right, so let's take it slow now. A5, x minus 1 over x squared minus 2x dx. And plus, I think if you guys remember me saying this to you, so from that moment onwards, any question you're going to get, you should assume it's a log for integration with fractions. Assume it's a log. If the log test fails, then you know it's something else. All right, this is a log, but if we use the same concept that we just did with the reverse chain rule, what's the derivative of the bottom? We said 2x minus 1. But what do we actually want? An x minus 1. What do you mean by minus 2?
The derivative of the bottom.
Yeah, but isn't it 2x minus 2? You factorize, you get 2x minus 1. So you get 2 bracket x minus 1, but you only wanted x minus 1. How do you make a 2 into a 1? Half it. So the answer should be half log x squared minus 2x. Are we okay with that? If not, remember the trick I told you one of my students said to me? He's like, look, what we could do is differentiate the bottom, which is what we've written here in blue. Factorize it, cancel it out. What are you left with? 2 on the bottom. So you can always just put half and then obviously knowing that it's a log. Only works for logs though, that trick. So you could always do that as well. If you feel like you didn't know it was half for any reason. And then you've got A and you've got 5. And then you've got half log 7/3. What can I do to both of the halves? Cross them out because they're both the same on both sides. Cross, cross. Here I'm left with log a squared minus 2a minus log 5 squared minus 10 equals log 7/3. You know where we're getting to it, right? We're getting pretty close. Log, what do you do when you subtract logs? Divide. Don't forget your log laws, which is something that I think you guys do need revision on. 5 squared is 25. 25 take away 10 is 15. What can I do now? Exponential both sides, so the logs cancel out. What can I do now? Times by 15. Not yet, you're very close. Times by 15. 15 divided by 3 is 5. 5 times 7 is 35. Now you'll solve for A. Bring it all over. That becomes A take away 7. A plus 5. A equals 7. A equals negative 5. I stop. I pause. I go back to the original question. What did it say? A is greater than 0. That's the 5th mark. A is just equal to 7. All right, your turn. Do the same question if you want, copy it down. Because I can see some of us are not comfortable with that. Right? Am I right?
I feel like, okay, it's just not like the first line. but
Wait,
the second
I
one.
want to write numbers. 1, 2, 3, 4, 5, 6, 7, 8, 9. Which lines?
2 to 3.
2 to 3.
It's just subbing everything in.
Yeah, so for what I've done with 2, I got rid of the halves on both sides because why not? It'll just make my math a bit easier. I subbed in A, minus, I subbed in 5. That didn't change. Then because we remember, the only way you can get rid of logs is if you've got a log on one side here and then a single log on this side. You can't have them both like that. So I combined them using my log laws and then, yeah, exponential. But it's more the integration. Were you happy with the integration part? Okay. That's usually the one that people have problems with. Aidan, what about you? You've been quiet.
Yeah. Yeah.
If I gave you line 2, would you be able to get to line 9? If I gave you line 2, would you be able to get to line 9? No. From line 2, where could you get to? Could you, wait, actually, from what stage would you be able to get to line 9? Line 5 to line 9? Line 6, line 4? Where do you feel like is your starting point? Where are you fully comfortable with? 4. So from 4 to 9, okay. So you got log laws and substitutions, integrations, okay. Okay. Last one, what about you? What line until you get to line 9? From what line?
5.
5. So even at 4, logs cancelling out. No problems. Okay. Anything else from that paper? Otherwise, it's a pretty straightforward paper. As you can see, it wasn't a big one. Just the second assessment task.